In the area of science and gigantic mysteries, the subject of what existed previously to the gigantic explosion has blended conversations and intrigued characters for quite a while. This huge request doesn't just test how we could decipher the universe, it challenges the genuine furthest limits of human knowledge. Imagine standing at the edge of existence, looking into the colossal shadowing and pondering what lay there before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. Anyway, was there a second earlier, previously this? Could there have been a condition of nothingness, a calm before the cosmic gathering started? And if this is true, was it? Or perhaps there was something much more alarming that existed previously before time itself. As we jump further into this question, science takes us on a journey past the universe's beginning point into thoughts that challenge our consciousness. Physicist Brian Cox, known for his investigation into the wonders of the universe, suggests that something surprising might have existed before the enormous detonation. He moves us to reconsider our thought of reality and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider secrets that might make sense of what existed preceding all that. We'll explore thoughts like self-important development, quantum changes, dark energy, and even multiverses. The answers we've revealed might just paralyze you, yet they could likewise open new understandings of our position in the universe. Get ready to jump deep into a world beyond imagination and science, where the obscure still winds around the shadows, leaving scientists floored and sometimes even upset. We ought to explore what existed before the Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we first need to painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, growing rapidly to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning with galaxies spreading out this way and that from an early stage. However, for what reason did this happen? Furthermore, was there a period before this thick hot start? As indicated by the theory of enormous expansion, there was without a doubt a previously, and it was not even close to void or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Anyway, this vacuum wasn't entirely unfilled. It contained a gigantic amount of energy that fueled the quick extension of space itself. This extension, called inflation, happened so rapidly that it basically established the groundwork for all that would continue in a part of a subsequent space, extended at unfathomable rates until the extension slowed down and the energy changed into matter particles and the forces we see as the Big Bang. But what was the nature of this energy? For what reason did it suddenly grow the universe, and why did it stop? Specialists believe that this inestimable expansion made patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly, with minuscule air pockets forming here and there, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our understanding of the very universe itself and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real at any rate, as per our current understanding. Regardless of whether you eliminate all energy, particles, and radiation from the universe, it would still not be genuinely void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable embroidered artwork of something, even in its most vacant structure. Regardless of whether we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy, except quantum fields and major constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a peculiarity called zero-point energy, which represents the least possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a spooky resonance of movement even in what should be empty space. This challenges our idea of a real void and suggests that yes, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe while inflation continues in different areas, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe might actually make its own Big Bang. Every universe exists as a separate, independent domain unaffected by the others because of the rapid expansion of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? How we may interpret nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, momentarily acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This constant movement in what should be nothing suggests that the universe doesn't recognize our concept of emptiness. The fields and forces endure, filling the universe with a hidden energy that prevents absolute nothingness. This understanding raises an intriguing question. If fields make particles and particles make matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? From certain perspectives, the fact that dark energy exists today is a leftover of an energy field from before our universe's development. The properties of dark energy seem to suggest a colossal hidden force that might have existed in some form prior to the Big Bang. Some theories suggest that dark energy, in a much stronger state, could have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that regardless of whether our universe were exhausted of all matter and radiation, this force would continue to expand the fabric of space-time. This thought leads to an upsetting question. If dark energy was present before the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe goes through endless cycles of birth, death, and resurrection. In this model, the Big Bang is not a one-time event but rather part of a timeless rhythm, where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe might have been reborn from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an eternal series of universes emerging, growing, and renewing themselves over and over again. Cyclic cosmology raises significant questions about time. as it suggests that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich answer to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves would be a groundbreaking breakthrough in our understanding of cosmology and might unlock the answers to what came before the Big Bang. Thus, the mystery of what existed before the Big Bang is one of the most profound puzzles in science. From the inflationary multiverse to dark energy and cyclic cosmology, the theories are as varied as they are mind-bending. But they all point to one tantalizing possibility: that our universe, and perhaps many others, could have always been part of an eternal cosmic cycle or a vast multiverse. Though the answers may elude us for now, they continue to challenge our understanding of time, existence, and reality itself, leaving us forever searching for what lies beyond the universe's birth. To further explore the mysteries of what could have existed before the Big Bang, we need to consider some of the more radical theories that challenge our conventional understanding of physics, time, and space. One such theory involves the concept of quantum gravity, which is an area of physics aiming to reconcile quantum mechanics and general relativity. Both of these theories are incredibly successful in their respective domains, but they are fundamentally incompatible. Quantum mechanics excels in explaining the behavior of tiny particles at microscopic scales, while general relativity governs the behavior of large-scale structures, like galaxies and black holes. The search for a theory of quantum gravity might hold the key to understanding what happened before the Big Bang, as it could explain how space and time themselves behave at the tiniest scales. One of the most promising candidates for a quantum theory of gravity is loop quantum gravity, LQG. In LQG, the fabric of spacetime is not a smooth, continuous entity as general relativity suggests, but instead is composed of discrete chunks or loops at the smallest scale, called the Planck scale. According to this theory, spacetime might have a granular structure, and time itself might not have existed in the traditional sense before the Big Bang. If this theory is correct, the concept of before the Big Bang might be meaningless. Instead of time stretching back infinitely, there might have been a pre-Big Bang phase, in which the classical notion of time breaks down completely. This would make the question of what came before the Big Bang fundamentally unanswerable, at least within the framework of our current understanding. Another intriguing theory to consider is the holographic principle. This idea suggests that the entire universe, as we experience it, could be a kind of hologram, with the true nature of reality encoded on a lower dimensional surface, much like how a two-dimensional hologram can create the illusion of a three-dimensional object. According to the holographic principle, all of the information that describes our universe could, in theory, exist on the boundary of spacetime. In this view, the Big Bang could be seen not as the beginning of the universe itself, but as the moment when the information on the boundary of the universe became real, creating the spacetime we perceive. If this theory holds water, it could imply that the concept of before the Big Bang doesn't exist, as the universe's boundaries and structure may be part of a larger, more complex reality. Furthermore, another possibility involves the idea of eternal inflation. Eternal inflation is an extension of the inflationary Big Bang model, suggesting that our universe is part of a never-ending process of inflationary bubbles. Each bubble could represent a separate, independent universe, while the space between them continues to expand. In this model, there is no true beginning to the universe. Instead, it suggests a universe that is perpetually spawning new regions, with each new region experiencing its own Big Bang, effectively creating an infinite number of universes. This idea echoes the multiverse theory but is rooted more in the physics of inflationary cosmology. If eternal inflation is correct, it could mean that the Big Bang wasn't the beginning of the universe but rather just one event in an eternal and infinite process. One of the more philosophically challenging theories that tries to answer what existed before the Big Bang involves the anthropic principle. This principle suggests that the universe is in some way fine-tuned to support life, meaning that the conditions of our universe are not random but are suited for the emergence of life forms like humans. Some versions of the anthropic principle propose that the reason the universe began in the way that it did is because, in a multiverse of infinite possible universes, only those with the right conditions for life would allow conscious beings to observe and question their existence. This would imply that what came before the Big Bang isn't necessarily important in a cosmological sense, but it is important in an existential one. If this principle holds any truth, it could be interpreted to mean that our universe's origins are inherently tied to our ability to perceive and contemplate them, with before becoming a relative concept contingent on the existence of observers. Another angle of approach is through the study of black holes, particularly in the context of the Big Bounce theory. This theory posits that instead of the universe beginning with a singularity, it could have experienced a massive collapse, a big crunch, that eventually rebounded, leading to the current expanding universe. In this model, the universe could have gone through countless cycles of contraction and expansion, with each cycle being preceded by a collapse that mirrors what happens inside a black hole. If black holes are gateways to other dimensions or forms of existence, this could offer a clue into what existed before our Big Bang, suggesting that the Big Bang was not a true beginning but the latest in a series of cosmic cycles, each one born from the collapse of its predecessor.